All right, thanks for your patience. Today we're doing calculated integrating, and we're looking at example 1 here, which is the integral from 0 to 3 of 2x dx. And since this is a straight line, we can just graph the straight line. So if you plug 0 into this, you get 0 out. If you plug 1 into that, you get 2. If you plug 2 into that, you get 4. And if you plug 3 into that, you get 6. So then you got your straight line that goes through 0, 0. And we're just trying to find the area from 0 to 3. So that means we're just trying to find the area of that triangle there. So that'll be 1/2 times the base of the triangle, which is 3, times the height of the triangle, which is 6. So you take 1/2 times 3 times 6, and that comes out to 9. Okay, so that was method 1. So what's another way to do this? Yeah. Yeah, you can take the limit as n goes to infinity of the sum I equal 1 to n of a bunch of rectangles, right? Okay, so the topic for today is, in that method, that's pretty painful, right? Well, the topic for today is another method. Remember we used to do derivatives? Limit as x goes to 2 of f of x minus f of 2 all over x minus 2, and that was really painful. And then I said, oh yeah, by the way, there's a button for the calculator. Well, same thing with integrals. By the way, there's a calculator button that can calculate this. Okay, so I'm going to show you that. Some of you have probably seen it already. So what you do is you press Math 9. So derivative is Math 8, and integral is Math 9. See where it says fn int? That's called function integrate. So there's the derivative is Math 8 there. Don't forget about that. But also today we're working on Math 9, which is function integrate. So then you get this integral thing up on the screen, right? So then you just have to plug in 0 to 3. And then 2x dx. And you press enter. And it gives you 9. So very good. So it's x squared, comma, 0, comma, 3, comma, x, I think. Did that work?
X squared, comma 3, or x squared, comma 0, comma 3, comma x.
Yeah.
Give me there.
So maybe the x has to come first. So try Math 9, x squared, comma, x, comma, 0, comma, 3.
Where's x squared?
Yeah.
Never mind.
You got it, very good.
Yeah, so
So this is how you do it with an old-fashioned calculator. Okay, so this method was pretty tough. It's not. Okay. So now let's just practice a couple. Let's practice the integral from -1 to 2 of x sine of x dx. That's for part A. And then for part B, let's practice the integral from 0 to 1 of 4 over 1 plus x squared dx. So you just press Math 9, and then type that stuff in. So -1 to 2 x times the sine of x dx. Press enter. This one should come out 2.043. You always round to 3 decimal places, right? AP Calculus test wants you to round to 3 decimal places. So every time, 3 decimal places.
I got oh, come on. Oh, wait, don't
Bryn, you good?
Oh, right.
Yep, you gotta be in radian mode, that's true.
Yep.
Yeah.
So where are we supposed to plug in the hours? Because for the last one, we plugged in x squared.
I was just wrong. You should have been plugging in the function 2x.
Oh, okay.
Oh.
Sorry about that. I was thinking about something else, but yeah. You should have been plugging in the function. My fault. Yeah.
Which order do you put them in? Yeah.
Now you're good. You had the right thing typed in. Thank you. So then try the other one. Math 9, 0 to 1 of 4 divided by 1 plus x squared. And that comes out to 3.142. That's true. That is pi. The reason why it's pi is because that's inverse tangents derivative. We'll talk about that later. Okay, for example 3, we're going to have a gas furnace. Heats a house. And uses gas at a rate of R of t equals 5t e to the t, and that rate is in cubic feet per hour. And then for part A, we're going to answer the question, how much gas is consumed from t equal 1 to t equal 3. So some furnaces work on electricity, but some use natural gas. And in fact, some even have, like out in the country, there's like a tank in the back. So yeah, where the gas company has to come and fill your tank every once in a while. So that's what's going on here. So there's a tank of gas in the back, and that's piped into your furnace, and then it burns the gas to heat the house. Okay, so this particular furnace is using the gas at this rate, R of t equals 5t e to the t. And we want to know how much gas is used from 1 o'clock in the afternoon to 3 o'clock in the afternoon. So if we were going to graph this function, the input is time, which is measured in hours. And the output is the rate of consumption, which is measured in cubic feet per hour. So the input is time in hours, and the output is the rate. So if we were going to find the area on this graph, I'm just making these numbers up. Let's say the height of this rectangle was 5. That would mean that the rate at which it was being consumed was 5 cubic feet per hour. And then if we were going from 1 to 3, that would be 5 cubic feet per hour times 2 hours. So then you'd find out that it used up 10 cubic feet of gas. I just made up the 5. So the point I'm trying to make is that if we find the area on this graph, that's going to tell us how many cubic feet of gas we use, which is what the question's asking. The question's asking how much gas is consumed from hour 1 to hour 3, so that we want to know how many cubic feet. So the actual right answer, I was just making those numbers up, right, would be the area from 1 to 3 underneath this rate function. So over here, I was just explaining that area was the way to go to answer the question. And now here, I'm going to find the correct answer to this question, which is the area underneath this rate function. Okay, so all we have to do is type in math 9, then this function from 1 to 3. So if I remember right from last period, that's 299 point, I don't remember the 3 decimals.
I get 200.
Gotcha. So 200.855, sounds good. And the label on that would be cubic feet.
What did we do to get that number? Like,
Integrated this function from 1 to 3.
but isn't the rate this 5? It's only 5.
Nope. I mean, I don't mean.
5T. Okay, gotcha.
So what was going on was I was making this number up.
Yeah, okay. That was
And then to get this, you should have been typing in math 9. Okay. So now for part B, the question is going to be, the tank had 500 cubic feet of gas in it at t equals 1. So now we're thinking about our tank out back, and at 1 o'clock in the afternoon, it had 500 cubic feet of gas in it. So now the question is, how much gas is in the tank at t equals 3? So that's really easy, right? It started out with 500 cubic feet. We found out in part A that it used up 200 cubic feet, so we just have to take the 500 minus the 200.855. So that's the number I was remembering from last period, I guess. Did I get this 145 right? Cool. Okay. Let's try. Now we're on to example 4. So a car uses gas as well, right? But a different kind of gas. This is liquid gas instead of natural gas. But a car uses gas as well. And a family takes a trip to Nebraska. They're going because they want to see a decent football team play. I should point out that this year Nebraska beat Michigan State. Michigan State beat Ohio State, so I'm sure Nebraska could beat Ohio State, of course. That logic always works. Okay, so anyway, a family takes a trip to Nebraska, and the number of gallons in the tank at time t is given by g of t equals 12 minus t squared. So there's a gas tank, right? And the engine is using up the gasoline, and this is how many gallons are in there at a certain time. So then the question is, what is the rate of consumption at t equals 4? Okay, so again, we're going to look at this graph, and this graph would input time, which I don't think I specified yet, but let's say the time's in hours, just like on the last problem. And then this time, the output is the number of gallons, right? So in other words, if I plug a 1 into this formula, 1 squared is 1, 12 minus 1 is 11. So this time it's going to be a little easier to understand, Dan, because I'm not making numbers up. So that means at 1 o'clock in the afternoon, there's 11 gallons in the tank. And then I could plug a 3 in. 3 squared is 9. 12 minus 9 is 3. So this is quite the gas guzzler of the vehicle they're driving. Maybe it's the family camper, because it used up 8 gallons in 2 hours. Okay, so the point I'm trying to make here is that if you found the area here, if you took 11 gallons and multiplied by 2 hours, that would come out to 22 gallon hours, which doesn't make any sense in this context. If you take gallons times hours, you get gallon hours. That's not what we're looking for. We're looking for the rate. We're not looking for gallon hours. We're looking for the rate of consumption. So we've been doing a lot of area problems. And so sometimes you just kind of say, oh, I'm going to do area every single time. And that was true on example 3. We did area on example 3. But on this problem, area doesn't make sense. Instead, what makes sense is the slope. Because the slope is the number of gallons per hour that are being used. Okay, so this doesn't make any sense. Instead, we're going to take the derivative. Derivative of 12 is 0. Derivative of t squared is 2t. And so then we're going to plug in the 4 to figure out the rate of consumption at 4. And so apparently something is wrong with this engine, because if it's using 8 gallons in an hour, that's crazy. But anyway, you get the point. What makes sense here is the derivative. And we could have used math 8 for this derivative, right? If it's calculator active, you could have done math 8 of 12 minus t squared, comma 4, right? But this derivative was so easy, I figured that we'll just do it by hand. Everybody doing good? Okay, so that's all the new stuff for this semester. So what that means is that you have a test coming up next week. That'll be your second test for this quarter. You also have an exam coming up the week after that. So the homework over the weekend is not hard at all. But I would highly suggest starting test review or exam review or something else. Otherwise, next week and next weekend are not going to be fun. Yeah?
So is Monday one of your review day and the test is like Tuesday and Wednesday?
The test is Thursday and Friday.
Oh, okay. So Monday, Tuesday, and Wednesday are all review
Yeah, we'll figure that out as it goes, but yeah. But everything's up. All the test review, all the exam review, everything's up already, so you should be able to get started on that. Okay, before you get started on your homework, though, we have a Calculus the Musical song today.
You don't want this recorded?
Yeah. Yeah, I don't really want to do that.
Record the calculus and musical too.
Yeah. Yeah, I need somebody to hold this.
I will.
I'm serious. Yeah. So just like stand over here and hold it there. Okay, now I gotta get my other. Yeah, this is technology overload for me. I can't do this.
So, is it gonna be able to hear it?
I don't know. We'll see.
GFB, renowned, no opinions. To find the whole area under the curve, under the curve, under the curve. To find the whole area under the curve, under the curve, under the curve. Interval. Epivax. Stay with me. Epivax, 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 Epivax.
See if you can keep up.